This video will have a look at using the process of adding and subtracting matrices to be able to calculate a missing variable or variables within one of the original matrix. The matrices can be added and subtracted together using the same rules as normal arithmetic. You need to be aware though that matrices can only be added and subtracted if they have the same order. So that means they need to have the same number of rows and the same number of columns. So if you've got a matrix with 2 rows and 2 columns and another matrix with 3 rows and 3 columns, those two matrices cannot be added together. They've got to have the same number of rows and the same number of columns. So if you have two matrices with the same order, so the same number of rows and columns, then to add and subtract, all you do is add or subtract the numbers in the corresponding positions in both matrices. So in our example, we would add A and E together, and that would become our first number in our added matrices. Then you would add B and F together, and that would become our second number in our new matrix. Then we can continue adding C and G, and then finally D and H. So after we have added or subtracted our matrices together, we then have a new matrix. That is the final result. So let's now have a look at an example of how we can use this process to be able to calculate some missing variables. So in the example, we want to be able to calculate the values of A, B, and C. And you can see that those A, B, and C values are within our original matrices, and that we are subtracting those matrices to get our final answer. So to be able to calculate our values of the missing variables, we can work backwards from the final matrix to be able to work out what those variables are going to be. So looking at element 1, 1 in each of our matrices, we have 12, 9, and 3. And because we are subtracting, we know that 12 minus 9 is equal to 3. So having a look at A, the corresponding element in our middle matrix is going to be 9. And then in our answer matrix, the corresponding element is going to be negative 3. So we know that A minus 9 is going to equal to negative 3. So we can work out what our value for A is by adding 9 onto both sides. So that leaves me with A is equal to 6. And I know that 6 minus 9 is equal to negative 3. So by working backwards and then solving the equation, I can work out what my missing variable is going to be. So following the same process for B, the corresponding element in the first matrix is going to be 20, and then the corresponding element in the answer matrix is 21. So I know that 20 minus B is going to equal to 21. So I can subtract 20 from both sides, and that is going to leave me with negative B is equal to 1. But I don't want a negative B, I want a positive B. So I can divide both sides by negative 1. So negative B divided by negative 1 will make it into a positive, and then 1 divided by negative 1 will be negative 1. So my B value is going to be negative 1, and I can check that 20 minus negative 1 is equal to 21. And finally C, my corresponding element in the first matrix is going to be 13, and the corresponding element in the answer matrix is going to be 8. So that leaves me with 13 minus C is equal to 8. I can minus 13 on both sides, so that will give me a negative C is equal to negative 5. Because I don't want negative C, I can divide both sides by negative 1, so that it will leave me with C is equal to 5. And I can check that 13 minus 5 is equal to 8. So being able to work backwards and solve each of the equations, I can determine my value for A is 6, my value for B is negative 1, and my value for C is equal to 5. So that is an example of how I can use the process of adding and subtracting matrices to be able to determine a missing value or values in my original matrix.